Hello. Hi guys, good morning. Welcome back to a new video. Ki hal chal? I hope you guys are doing good. In this we're going to see minimum limit of balls in a bag. It simply says that you are given an integer array nums. As you can see, integer array of element nums is given with ith bag. So this is each bag. I have, let's say, four bags having these many number of balls, nums of number of balls in each bag. And I'm also given a variable called as max operations, one variable max operations. Now you can perform the following operation at most max operation number of times. What is the operation? Each operation looks like that you can take any bag of a ball of having any number of balls and divide it into two new bags with the positive number of balls, which means if I have a bag, again this is one bag, this is one such nums of I can divide it into two bags of any size, but that size should be positive. I cannot divide it into 0 5. It should be a positive size. So I can have a 1 4, a 2 3, a 3 2, a 4 1, and anything whatsoever, right? But it should be two back divided into positive. This is called as one operation. This is one operation. Now, okay, obviously, then you have multiple such options to have one operation. Your penalty is the maximum number of balls in a bag. So considering if you were allowed only one operation, then you would do something of this sort. Obviously you have multiple options to divide to. Then for this the penalty here will be 3, which is the maximum number of balls in any of the bags. Ultimately it was divided into two bags, but maximum balls will be the penalty. Here in this case the maximum balls is actually 4 in one of the bags, thus the penalty is 4. You want to minimize your penalty, so technically in this example for 5 balls, if you had one operation, you would have divided it into these two bags of having a configuration of 2 comma 3. Now your task is to ultimately give us the minimum penalty considering you divide the balls. Obviously in this case I have two operations and only one bag. Obviously, if I don't touch this bag, my penalty by default is 9, which is the maximum possible penalty I could get. Right? In this case, if I don't touch it, my maximum possible penalty is 8, which is the maximum number of balls in one of the bags. Now, obviously, I want to minimize the penalty, so I want to apply two operations. Now, technically, it makes sense that I will go greedy way, which means I will divide these balls by 2, as in these like 9 balls by 2. I will get 5 and 4. Then I will again take the maximum of balls, I will again divide by 2, which means I will get 3 and 2. So, technically, by this I have done two operations and I have achieved this configuration. Is it correct? Obviously it is not, because in this example itself, by my greedy way I would have achieved maximum balls or maximum penalty of 4, while the answer is 3. So obviously this is incorrect. Now when this is incorrect, then what? Then again, whenever greedy is incorrect, we tend to go towards a normal brute force way. But as we were seeing that for every ball, let's say I have x balls, then I have multiple options. Either I can have 1x minus 1 configuration, then 2x minus 2, then 3x minus 3, and then so on and so forth. Then again this can also be configured, so it seems like, again, and along with the maximum operations allowed. So it seems like that when I say brute force, I could have a corresponding recursive thing, and maybe I can memorize that by dp and ultimately achieve my result. That's the next intuition which I could get. But if I try the corresponding brute force, and that too corresponding, obviously we go ahead with recursion and then try to memorize it, we will realize that for each bag it has x number of balls. Now the maximum limit of x itself is 1e9. So this division itself, this thing can go at max 1e9. I have not even considered the fact that it will go down also in the tree traversal. As in, like, when I say tree, I mean simple DFS, which is a simple recursion. So technically for each ball you have n balls, and also the horizontal width, how you will partition it, depends upon nums of I, which is 1e9 in this case. Thus obviously you will get TLE even if you memorize it. Oh, so this kind of brute force to memorization will also not work. Then what? Okay, let's come back and look at it again. Think of a brute force approach again, but now in terms of that, okay, let's consider max operation and the balls also parallelly. But again, we are again going back to brute force, and we have tried so far the most intuitive things first. The main problem of this entire problem itself is to think of what will be applied, right? So now what we will do is that ultimately my maksat was to get as minimum balls, or I should say get the maximum balls in the bag as minimum as possible. This was my ultimate maksat, right? Maksat नहीं बोलना है. So your primary aim in this is go and try by yourself, simply brute force, go and try by yourself all the possible max values which you can achieve. Consider the very basic case. You have only one bag having 9 balls. So what all possibilities I could try for is, okay, let's try for the maximum possible balls in a bag as 1 or 2 or 3 or 4, 5, 6, 7, 8, 9. I cannot try for higher than 9 value. Why, you will ask? Because obviously I have only 9 balls. I cannot put any ball. I can only divide the balls, which means I can only reduce this. And obviously I can achieve one ball. How? In a bag? Simply, I'll simply ask that I have to achieve maximum balls in any bag should be one. In that case, I will simply say, okay, put one ball. Obviously I know I have 9 balls. I have to divide those balls such that each bag has now at max one ball. So I will divide into 9 bags. If I divide into 9 bags, the operation required will be 8. Think of it right now. I will tell you later on why it is 8. But again, operation required will be 8. Now, if I want to divide my balls as, okay, every pack can have at max 2 balls, then I will simply try to divide 2, 2, 2, 2, 1. Operations here required will be 4. As you can see, bags are 5, balls are 4. But again, the condition is satisfied that I have each bag having at most 2 number of balls. But Aryan, were you, if you are saying that it was able to achieve, then why you did not return 1 as the answer? Because technically you want to get minimum of this max balls in a bag value, because you want to minimize this, because that is your penalty itself. Because this is your penalty. If I replace this is actually the penalty itself for me. I want to minimize this penalty. But I saw that to achieve this configuration, my operations required were 8, but I was allowed only 2 operations. Here in this case, the operation required were 4. I was allowed only 2 operations. But as I go on to the next higher penalty, which is 3, I will ask, is it achievable? Obviously, he will say, okay, you will have 3 bags having 3 balls. And obviously, with that, operations required will be 2, which is less than or equal to the max allowed operations. And thus, you are good to say that this is the first ball or first configuration or first max balls in a bag of first penalty, which actually is minimum and also gives you the corresponding result in this limit of max operations. So technically you would have tried on all these max balls value, and you might say, Aryan, but like are you sure about this? Because obviously what you are doing is that you are trying for this entire configuration, which is 1e9 in this case, and then you are also saying that you will try for all the balls which are n balls. So Aryan, isn't it again n into 1e9? I'll say true. Yeah, you are exactly true. It is again n into 1e9, because you will try for n balls and each ball can have at max these many configurations. Why not think of a pattern here? The pattern itself is you were trying for one bag. Again, this was for one bag, one original bag. You were trying for minimum value, then higher value, then higher value of penalty, then higher, 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 and so on and so forth. You are trying for the high value of penalty. You realize that these were not possible. Then obviously later on things will be possible. As you can see here, I did the configurations and operation required 1, 1, 1, 1, and 0 operation required. So obviously, like, does it bring or ring any bell? Obviously, it rings the bell of binary search, because binary search itself is a pattern where in half portion it is wrong, it is right. So you can simply do a binary search to know what is the first right portion which you have to come to. So what I will do, I will simply apply a binary search. Now obviously binary search on what range? I saw that binary search will start from, okay, I can have a minimum, because obviously I want to distribute the balls such that each ball has a positive number of, each bag has positive number of balls. So I will put by default 1 as the minimum. So 1 is the minimum number of penalty or balls in my bag. What is the maximum? As we saw earlier that I told you, the maximum is 8 here, the maximum is 9 here. What is the maximum? Maximum was actually my maximum value of nums of I in the entire array of nums. Oh, thus I got to know what is my L, what is my R. Then I can simply apply the binary search. Now, if you don't know the template of binary search, although binary search is nothing but nothing to have a template of any sort, but still, if you get confused or if you write the binary search code in less than 30 seconds, then you need to watch a template, or you need to have a template, because see, there are multiple ways to write binary search. We have a way of while L is less than R, we have a way of while L is less than equal to R, but you need to pick up some way that you can write the binary search code in under 30 seconds. And I'm not saying the actual logic of is possible, no, only the template of binary search you should be able to write. The is possible logic, which is the root, the brain of binary search, you can write at your own pace, but this portion you should be able to write in 30 seconds. Now coming on back, the main, as I told, the root is the is possible thing, and for sure is possible will define for any number which I have taken here, which is obviously L and R is here, so I will get a mid. Mid is nothing but my, it will tell the balls in a bag. It will tell me the current balls in the bag. I will have to compute the number of operations. If those operations are less than equal to the max allowed operation which I am given, then I will say that this is true, and then I can try for a lesser value as I do in a binary search. So what I will do, obviously, I need to figure out at any random mid, mid value will be nothing but this max balls in a bag. I need to figure out how many number of operations will be required. Firstly, let's say I'm allowed maximum balls of 4. Obviously, for that bag, I'm given 9 balls. The task now here is divide those 9 balls to how many buckets, because if you remembered, these are 3 buckets such that each bucket has at max 4 balls. Simply now you are given that 9 balls you are given, divide into some number of buckets such that each bucket has 4 balls. So obviously you will try as max as possible. So you will try 4 balls in the first bucket, 4 in the next bucket, 4 in the next bucket. Oh, Aryan, this became a 12. You required only 9. Oh, that is true. Which means that I will simply divide it into so many number of bags or buckets that I am fulfilling that 4 maximum value. So 9, when I did a seal division by 4, again, why seal division? Floor division will say me 2, which is this thing. Seal division will say me, okay, this thing, which means what if I would have done 4 for 4 equally? Then it will give me 3. So I am required 3 buckets. Now I asked you in the very beginning, what is the number of operations? Buckets are 3. Operations required will be 2. Because obviously, if you have a cake like this, let's say if you have a cake like this, I ask you to divide this cake into 3 buckets. Again, I'm not saying equal, I'm just saying 3 buckets. Then you will do a 1 cut here. Okay, you have 2 pieces. Then you do another cut here, you have another 2 pieces. So by 2 cuts, or I should say 2 operations, you were able to achieve 3 buckets, right? That is the reason, if I have 3 buckets, operation required will be 3 minus 1. Thus this is my corresponding number of operations, which is bucket minus 1, and thus I will put it here and will ask if it is less than maximum operation, then this thing, this max ball which is at the mid is possible, and then I will try for a lesser value. Let's say the code is exactly simple. Firstly, I put my L as 1 and R as the max, and then I initialized my answer by the maximum possible value. Then I did a simple binary search template. I went on to mid. I checked if it is possible. If yes, then put up your answer. Go and try for lesser value. If not, then try for a higher value. Ultimately, return the answer. For is possible thing, I'll simply go and check what is the operations required because of this max balls in a bag, which is the mid for us. I'll simply iterate. I will find the ceil value of num divided by max balls. This will give me the number of buckets. Number of buckets minus 1 is the number of operations. If this operations is, again, obviously I will have to add in my total operations because I am doing it for each and every bag. So if that is more than my max operations, then return false. Obviously, you should not even go further. But if not, then simply return a true. Again, this is kind of pruning method. Although if you would have if you would have put a condition here also that total operations, if it is more, sorry, if it is less than equal to max operations, then also it would have worked. But this is kind of a pruning that it will not unnecessarily go to next bags if it figures out that it's not even possible, and ultimately that's your code. Cool. The time complexity for this is, as you can see, this piece of code which will take log of your num value, which means log of m time. M is the maximum value of nums of I. This piece of code will take this much time, log of this value, while is possible every time it iterates on all the elements, it will take O of n time. So it is n log m, and obviously no space used. Cool. I hope you guys got it. Again, it's simple, but in terms of implementation, but to think of what's going to be applied is actually the main crux of this problem. Now, if you guys liked the video and if you have reached so far, I'll highly love if you would like and put any comment whatsoever you learned or anything in that video. Again, it motivates me a lot. And yeah, that's it. Bye bye. Take care.